I want this video to be about lighting in Bryce, but to some extent that means it's also going to have to be about materials, because you need the light to interact with something. So I'm going to create a default sphere, and that's going to come in default material, and I'll just bring the camera in so we can see that a bit closer, and go into the material lab, and you can see we've got 100 diffusion and the diffuse channel set to grey. So that's very basic material. I'm going to Control C, Control V to create another sphere. Move that across, holding the Alt key down while using this control allows it to go in discrete steps, and modify the material for this one to the next channel, which is 100 Ambience. And then I'm going to Control C, Control V, create another sphere, go into the material lab here, turn the ambience down, turn the specularity up so you see the specular highlight. Control C, Control V, and move that across, and I'll make this one 100% reflective. So this is our lineup. So each of these is a separate effect. I'm just moving the camera around so you can get a good render view on this. So here's our diffuse, ambient, specular, reflection. Now, reflection is not really a response to any light source, but it is creating an effect on the object. So it's like the object's lit. It's just showing us the environment here which we're in, which is the default sky. And diffuse and specular are all responding to the direct light from the sun, and the sun's output is in diffuse and specular as well. And if we go into the Skylab, you can see this is the sun intensity control, and if I do render in scene here, you can see we've got the diffuse and the specular, and the ambient is here. Now the ambient, I would encourage you to only use for special effects, not for lighting, because it's a very basic form of lighting. So I'll make it bright red. You can see that this material's responded immediately, but it's just a circle in the render. There's no three-dimensional form. It doesn't really tell you it's a sphere. So the ambient was put in there to make up for the fact that on slower computers you couldn't produce very high quality lighting, because that meant having to include a lot of light sources or use global illumination methods, which we'll touch upon later on. So in this case, in terms of controlling the lighting, we have the option of turning off the diffuse, and you'll see the ground's disappeared and the sphere on the left. We can turn off the specular, and that specular highlight disappears. If we turn the diffuse back on, you'll see that this with a specular responsive sphere here still remains black. The only way to get the sphere with its fully reflective, fully black, would be to alter the environment so that there was no sky and nothing for it to reflect, but it should, if it could see it, reflect the ambient ones. If we turn the atmosphere off temporarily and set it to fully black, you can see now that the reflective one's gone fully black. If I lift it up a bit, there'll be a bit of reflection from where it can see a bit of this ambient sphere there. So that's the way to deal with that. I'll just shuffle it back into position and go back to custom sky, or what, it doesn't really matter. I just want to, in fact I'll just reset the sky so we're back at default. Now, things to be aware of in terms of the sky, I've covered this before but it's important, is this sky dome colour acts as a light source that shines from above but doesn't cast any shadows. So if we turn the sun off temporarily, so that means turning the diffuse off and the specular off, and we've got this sky dome, you can see although it lights the top of this sphere and produces a gradient, and it will work with bump as well, it doesn't cast any ground. So that is another crude form of lighting that was introduced because of slower computers, like ambient in a lot of ways. You can see the ambience working in here, so I was going to make that a red colour, wasn't I? So sky dome ideally wants to be set to fully black all the time. And another important thing is this sun moon shadow, so I'll just turn the sun and the moon back on. Now, this control is a global control for all direct lighting for shadows. So if you turn this down to very low or turn it off, none of the light sources in your scene will produce any shadows. So if I quickly create a radial light over this scene, even though it's neither the sun nor the moon, it won't be casting any shadows because it's being governed by this global control here. So this ideally at all times, if you're using more sophisticated lighting methods that are now available in Bryce 7.1 Pro, wants to be turned up to 100. The other reason for turning that up higher is that it affects the render time. Because it essentially lets light travel through solid objects, it means it's stimulating more rays to be calculated, because a ray that might have stopped on this surface then stops on that surface and also travels a certain proportion of it, dependent on this setting, through the object and then reacts to other things. So you can imagine it's like turning all your objects a bit transparent, which creates a lot more work for the render engine. So set that at 100 wherever possible. Okay, right. Now in most materials you will have a mixture of different effects. So we'll take this one, for argument's sake, it doesn't matter which one, copy and paste it, I'll move it back a bit and then enlarge it, and then we'll combine some effects together. So this is our larger sphere, if I can position it so we get a look at that as well as the other ones in shot. Go into the material lab for this one, I'll give it diffuse. I'm not going to give it ambient. I would encourage you to not use any ambient in your materials at all unless it's for a special effect, like you want it to glow like fire or plasma or something like that. And we'll give it a bit of reflection. So it's going to reflect a bit of the environment, it's got a specular highlight and some diffusion. So this is more what you'd expect when you're working with the material, probably much more complex than that, but it combines multiple components. Now the thing to note about this is that these components are added together. So if you started with a default grey and then you add a specular highlight, and the specular highlight there, if you look at the size of it, is added onto this grey, so it's burnt out in the middle, and likewise the reflections also getting added on. So this is where it comes to controlling your lighting environment through these various effects. So as you combine things, they get added on. Now this isn't, strictly speaking, realistic. In the material options you can apply 100 reflection, you can apply 100 transparency, and the result of all these things getting added together in this way is a very bright material. It's good for creating special effects, but you need to utilize these settings appropriately to create the right material effect. Like, for example, you might argue that it's a bad idea to have 15 reflection with 100 diffusion. Maybe you should be looking at 85 diffusion, because so much of the light is reflected, it's not going off the diffuse surface. And there are other settings in here which will affect, like I'll just show you this briefly. Supposing we've got this reflection and the diffuse colour modifies the reflection. If you increase metallicity, the metal materials modify the colour of the light that interacts with the surface when it gets reflected. You don't get this with anything that's non-metallic. It's some atomic property, as I understand it. Anyway, that's a digression. So careful setting of these material options is one way to get the right effects, but another is to understand the lighting situation. So this is our basic lighting situation, and for the sun we have the option of controlling the specular and the diffuse separately to create different effects. But the sun's only the simplest lighting setup. What you probably want to do after you've set your scene up is produce more sophisticated lighting to create the effect you want, probably going to look more realistic depending on the subject. So we'll go into image-based lighting tab and we'll use HDR image, and I'll open one of Horrors, this garage closed, and that'll be applied. Now as a result of applying loading in this HDR image, it's automatically disabled the sun, which is fine, and it's given us some default settings, but you can see the scene's rather dark. So we'll increase the HDRI effect so it lights our scene, and then you can perhaps see in this preview, but you will see it on the main render, that our specular highlight has vanished. We're still getting a reflection of the sun because the HDRI has been incorporated with our existing sky, but we're getting no highlight, and you can see the reflection of the sun just here as well. The interesting thing about HDRI reflections is because it's treating the reflections in a high dynamic range and they're only getting resolved to low dynamic range once it reaches a screen, then there simulates reflections very effectively. So what to your eye on the screen or in this preview, I'll just turn that up so you can see it, may look like fairly similar light levels are actually radically different, and then with the reflections, when because it's attenuated by only having, well, I think it was 15 reflection, you can see the lights themselves. So they're burned out there, big blocks of light, but in the reflection we get narrow strips of light because they're the bright source. So that's a good reason, but I've not explained it very well for using HDRI images, but that's a slight digression anyway. What I'm more concerned about is where's my specular response going to come from for this material. I could, as a simple solution, just turn the sun back on, but it's all got a bit bright there, but I can always control the diffusion level, and that gives me my specular blob. But what about specular from the HDRI? So I'll disable the sun again and go in the image-based lighting tab and turn the specular up. There's a slight modification there, but there wasn't much specular, and this is a problem with the way that HDRIs are generated. They don't produce much specular, and if you want specular output, you need to find a way of increasing that value. Well, that's the maximum setting, but there is a control here that says apply to light source, and what this does is it acts as a multiplier between the intensity and these two controls. So now you can see things got a bit bright. We need to reduce the HDRI effect, and then we can increase the intensity, and we'll start to get some specular highlights as a result of the simulated light sources that have been generated that produce the effect of the HDRI lighting. So now we've got these on. You can see that there are a few distinct blobs in this preview, but this preview is only generating about 16 light sources, which is the lowest quality setting. The default setting comes in at 256 light sources, so we should see a greater spread of blobs than we see in the preview. So these blobs are actually occurring, and there you can see them on this, just on the specular response here, where the simulated light sources have been generated to light this scene, and appropriately many of them have been placed over where the fluorescent lights are in the scene. If I go back into the image-based lighting and lower the quality, then you'll see something more like you have in the preview, and the number of light sources have been reduced and there's more shadows. You can see that there's distinct shadows, and this is because it's limited to the number of light sources that it's been able to create to light this scene. The light sources are chosen in the sky by an algorithm, and I can't remember whether it's Monte Carlo or median cut. Anyway, it was one of those two. Horror knows better, and it doesn't really matter. Well, it matters technically, but otherwise it's just to determine where these light sources are placed in the sky, and the colour and the intensity is according to the HDRI provided. And as you can see, things are getting added up. Now, if, for example, you can't get enough specular without turning this right up, we'll turn the intensity of the light down, you can see in the background the backdrop's getting rather bright. So if this was the kind of effect you were looking for on the material, but you didn't want the very bright backdrop in the reflection, you have the option here, thanks to this control transparency, you can reduce the intensity of the backdrop, but it's reducing its perceived intensity in terms of it being applied as a backdrop. I can just move that view around, not affecting the amount of light that it's producing. So that's sort of handy too. Right, I'll set this back to where we were before, to the basic levels. Specularity, we'll just turn that down. Oops, we can have negative specularity and negative diffuse for special effects as well, which is nice. Okay, I'll turn that back up to 50, turn the transparency down to 0. Okay, so here we are with our HDRI lighting. This is direct lighting. This is coming from the light sources in the sky, and even though we've not got our specular response at the moment, there is a little bit there. The final sort of lighting to consider is an indirect lighting mode. So render options, premium effects, turn the rays per pixel down for previewing, true ambience, scattering correction for it's the best level of simulation that we've got at the moment, maximum ray depth 4 to improve render performance. Now in this case you can see things look quite different. What's happening is that the surface sends out probes into the environment, so we look at any pixel on the surface and then probes are scattered out into the environment, looking out in all directions and seeing what light source is available. Now if this sees this, it will then see the background or itself or the ground or this ambient sphere here, and through reflection and also through probing the environment still further up to the maximum ray depth to determine how bright that pixel should be. Now Let's consider a path where we'll look at this surface, and this pixel looks here and it sees a bit of reflection on this and sends out a probe and sees this. This means that this bit is getting slightly coloured red. Now this doesn't happen with direct lighting. Once it hits the surface, the story is over unless it's allowed to pass through it, or we're seeing reflection. So in some respects, true ambience is acting a bit, and I'm really reluctant to say this, like reflection, but you've got to imagine there is no bias from the environment that it's seeing. This is important. If there was any kind of bias, then you would see images forming in reflection, because that's a property of reflection. So this is really a scattering simulation. You could produce something very similar in the past, and you can still do it now, by using blurred reflections, but a blurred reflection still has a bias based upon the random distribution of the light as it dithers it around to see the surface. I'm sorry, this is getting a bit complicated now, I didn't mean to do that. The point is, when you switch over to true ambience, you've got to be aware that your image-based lighting the scene through this control still, and you might find you have to increase it to create better light, and a preview only shows the simulated light sources. If you want it to show a more sophisticated preview in the nano preview, accurate rendering will help you at this point, but slow down the preview here will mean that sometimes Bryce will be a bit unresponsive as it updates this little image on the left. The thing is that in the image-based lighting tab, the HDRI effect control is linked into the true ambience through true ambience optimization. So it's no longer producing direct light. So no amount of specularity when you've got true ambience optimization set and using TA rendering will make any difference to your image. To get a specular highlight at this point, your only option really is to introduce a specular light source. So as before, you could set the diffusion down and introduce the sun. This is a good strategy. And there you can get your specular light source if you wanted it, useful for creating like a plastic material effect. You can, in image-based lighting, disable the true ambience optimization, which means you are now producing direct light from the HDRI image, and that in turn will respond and react with the material as you'd expect, and the true ambience will then react with all these light sources and fill in your shadow regions nicely. But this is a very slow way of rendering. So if you're going to go for very high light simulation and good shadow modelling on complex models, particularly for still life, then it's probably better to look at my tutorials on obscure lighting, which is another way of incorporating the HDRI light directly out of the HDRI, not using true ambience optimization, and through linking with light from inside, non-shadow casting, and another object in the scene. In fact, I'll just show you. It's so much easier. Okay, so if I create a radial light here, I'm just going to change its family so you can recognize that it's not a normal radial light, and then I'm going to go into the material properties for this light and set it to default grey. An important step. I'm going to edit this light. It must be true ambience optimized. Use gel, include background. At this point you can modify the material by going in through procedural. It's the same short as it is long. We just need it to be default grey because it's going to receive direct light from the HDRI image. And an important step here is to make sure you've got it called background, because we're just going to target this as the light source. So I wrap it around my scene. You can see it's already changing the appearance of the render, even though it's invisible otherwise. And I need to go into the Skylab, into my image-based lighting tab, light from inside, no shadow casting, and then I include only the background, and I must be not selected on true ambience optimization. It's direct light into the inside of the radial light, which the surface will receive it even though we can't see it, true ambience sees it, and then it'll come back. And specular will work if you provide specular channel within the material and an output, but we're only going to use HDRI effect for this. So if we go out now and render the scene, we'll find that a different quality of lighting. This specular highlight must mean I've got the sun still turned on, so I'll just turn the sun off and we'll just work with the lighting provided from the inside of this light source. So you can see at the moment there's not a lot. You can increase the output here. We'll try 500, probably be too much then, we'll see. Okay, so the point of this is you're then able to utilize another control in your render options, and that will give you boost light option. You wouldn't normally apply this because it tends to introduce a lot of noise directly from the HDRI image, and you can see outside the light source we're seeing a lot of this additional noise, but inside it'll get cancelled out. And so if you want to cut that out, you can shield yourself on the outside by using yet another radial light that's specially modified. I'll call this one TA Firewall, and edit this and use True Ambience Optimization, UGL Procedural. In this case, set it default and then just make it fully black, and that can mop up the fireflies from the outside. You see they vanish now. So what's happening is the True Ambience, when you're looking at a portion of the ground here which is in default grey, is looking up at the HDRI image, and because the HDRI image is made of a high dynamic range components, very very bright and then less bright, more so than you would find in any other environment within Bryce if it's not high dynamic range, then it might see something that's bright and the next pixel might see something that's dark, and that's where your noise comes from. So to get the most out of True Ambient rendering, you need to utilize high rays per pixel, but obviously there's a price for this, nothing comes for free. You'll find the render time is quite slow, but if you're not providing any direct light, it will be a lot better than any other render method currently available. It'll give you the highest level of light simulation, it'll give you color transfer from objects, but it won't give you a specular highlight. So you can see this is going to take about 10 minutes now. If you introduce a direct light source, which I can do now quite easily by re-enabling the sun, and I'll just turn off diffuse, so we just wanted this for specular highlight effects, then I'll just check out of that and we'll see how that's affecting the render time. It might not be too bad, it just depends how much specular's in. 14 minutes, so everything comes at a price, but as you can see, these shadow regions are very well simulated. So I suppose I've given you a lot to think about there, and it's gone on a little bit longer than I anticipated and got a little bit more involved, but that's always the case. Essentially, consider that each component that in your material is added together. So if your material has a diffuse and specular, for a diffuse material alone, if your specular was covering a large proportion of the object, suppose you got a large specular halo, make that big, then these two combined, when they're combined, will create a large burned out area. So as you add lighting effects, you have to moderate the output of each, otherwise you will end up with a burned out result. And likewise with transparency, everything starts getting added together. So that's the main thing. And otherwise, consider the different outputs, diffuse and specular, of your different lighting. So here we've got no diffuse light, there's no direct light on this scene. We're handling everything through the light that's coming from the invisible light source that's wrapped around that's through the True Ambience, and that's really, in a lot of cases, the best lighting available to you, with the overhead of the time, obviously. But work your way up to this. Don't dive in straight away with the most complex lighting available. Set your scene up, try it with basic lighting, make sure that you've got everything set to fully black to start with, so you've got no other light sources like the sky dome colour or the ambience interfering with the lighting you have already there, because they'll only degrade the quality of the light when you start moving to more sophisticated light sources. And then add a little bit at each at a time, look at the render time, see whether the effect you're getting was worth the amount of extra processing it's going to take to achieve that result, and just experiment with it. So anyway, that's the end of the tutorial. I hope you found that interesting, and we'll go on to experiment with these lighting methods.